Hey everybody, Chris McClure here. We are going to now continue this discussion of solving equations, and this time look at equations involving roots, as in square roots and cube roots. And also we'll take a look at equations that are said to be quadratic in form. So it might look to be a fourth degree or some other form, but when you make a suitable substitution, it'll be quadratic. So we'll see how to do that. So first, radical equations. And equations involving radicals. So here's an equation involving a cube root, for example. Now your strategy for solving such an equation will be to get this radical by itself on one side of the equation and move the other terms over to the other side. So we'll just add 2 to both sides of the equation. And notice that the index of the root is 3. So that'll be the power that we raise both sides by in order to lift that cube root. We'll cube both sides. So when we cube both sides, we'll have 3x minus 1 is equal to 2 cubed, which is 8. And then a couple of easy moves to solve for x. Add 1 to both sides, divide by 3. Now, got to be super careful to check our work. Right now we're saying that the solution set is 3. But whenever we have equations involving fractions, meaning rational expressions, as well as radicals, we really should take the extra step to plug in our numbers, okay? So let's just go ahead and let's do a quick check. And you take the cube root of 3 times 3 minus 1, what do you get? You get cube root of 9 minus 1, which is cube root of 8, which is equal to 2. So that verifies that the equation really is true when x is 3. So 3 really is the one and only solution to that equation, at least real solutions. Now here's another equation here. And luckily for this equation, the radical is already isolated to one side of the equation, so we could just go ahead and square both sides to lift that square root symbol from the left. And on the right hand side you got negative x plus 1 squared, which gives you x squared minus 2x plus 1. So we have this equation here, and then we go about the normal problem solving process of solving for x as if that were a quadratic equation. So you can subtract 1 from both sides, and you know, who knows, subtract x, and you have x squared minus 3x equals 0. Factor it, x times x minus 3 equals 0. That means either x is equal to 0 or x minus 3 is equal to 0, which means x equals 3. So we have these 2 solutions, or at least what we think are 2 solutions, but it's always a good idea to check. So for one at a time, we'll plug those numbers into the original equation. Maybe we could plug 0 in for x. So you have 0 plus 1 is 1, square root of 1 is 1. On the right hand side, you've got negative 0 plus 1 is 1, and the equation is true. We could also plug in the 3 for x. We have square root of 3 plus 1 is 4, square root of 4 is 2. And on the right hand side, negative 3 plus 1 is negative 2. And you can see that the equation is not true when x is equal to 3. So we'll have to discard the solution 3. It's what we call an extraneous solution. But we will retain 0 as our solution. Okay? So we've tossed out the extraneous solution, and we'll keep 0. Okay, so 0 is our solution set. Find the real solutions of this equation here. Now this equation involves 2 radicals. So you'll typically, though, the strategy is to isolate the more complicated radical, in this case square root of 5x minus 1, and then add everything else to the other side. So you have square root of 5x minus 1 is equal to square root of x plus 1. Square both sides. So you have 5x minus 1 on the left, and on the right-hand side, square root of x plus 1, quantity squared. You'll FOIL that out. You have square root of x squared, which is x, and 2 times 1 times square root of x, and then plus 1 squared. Then take this equation, isolate this radical there so you could solve for x by getting rid of that square root symbol. So there we've subtracted 1 from both sides, subtracted x. So you have 4x minus 2 is equal to 2 times the square root of x. Divide both sides by 2. So now you have 2x minus 1 is equal to square root of x. Square both sides so we can get rid of that radical symbol on the right. On the left, you have 2x minus 1 squared, which is 4x minus, excuse me, that's 4x squared minus 2 times 2x plus 1 is equal to x. So now you have this quadratic equation, which you know how to solve. Maybe subtract x from both sides. So now you have this equation. See if you can factor this left-hand side, which will give you 4x minus 1 times x minus 1 equals 0. And then set each of those factors equal to 0. If 4x minus 1 equals 0, then you have x equals 1/4. Or you have x minus 1 is equal to 0, which means x equals 1. So you got these two numbers. Let's plug in each one of those numbers into the original equation to see whether or not each one of those numbers is really a solution. Maybe we can plug in 1/4 for x. And then you would have square root of 5 times 1/4 minus 1. Now 5 times 1/4 is 5/4. And then you could subtract 1, which could be written as 4/4. 5/4 minus 1/4 is 1/4. So you have square root of 1/4. Minus square root of 1/4, which is 0. And that's not equal to the 1, which was the right-hand side. So we could see that 1/4 is not a solution. Now let's check x equals 1. Okay, let's check x equals 1. When you plug in 1 for x, you get 5 times 1 minus 1, which is 4. Square root of 4 minus 1 is really equal to 1. So we will retain 1 as our solution. Okay? So make sure that you are checking those answers. Now let's take a look at solving equations that are quadratic in form. So let me tell you what I'm talking about here. Look at this equation right here. X minus 2 squared minus 3 times x minus 2 plus 2. Well, you take a look at x minus 2 there and there. If you were to do a little substitution, u is equal to x minus 2, then you would have u squared minus 3 times u plus 2. And now that looks like more of a recognizable quadratic equation, which then you could solve maybe u minus 2 times u minus 1. Okay, u minus 1 is equal to 0. Means u is equal to 2, or u is equal to 1. That means that x minus 2 is equal to 2, or x minus 2 is equal to 1, which means that x is either equal to 4 or 3. Okay, so that's how you do that problem. Okay, so that's basically what we're doing here. Just did that substitution, and we got the answers that we were looking for. It's always a good idea to go back and plug in your work just to double check that there aren't any rational expressions or radicals, so we're pretty sure that 3 and 4 are the two solutions. All right, now look at this equation right here, and it doesn't look like a quadratic equation, but if you were to do the substitution, let u be equal to square root of x, then you would have u squared minus 5u plus 6 equals 0. So that's what we're doing there. We're substituting square root of x for u, or substituting u for square root of x. So you have this now, this quadratic equation, which we can solve using whatever method, in this case factoring. solve for u, and then u is the square root of x, so replace u by square root of x. It means square root of x is equal to 3, or square root of x is 2. Square both of those numbers. X is 9, or x is 4. And it's a good idea at the end here is to plug in each one of these numbers, 9 and 4, and make sure that the equation is true for both of those. Okay? So there's your solution set, 4 and 9. All right, let's talk about solving equations by factoring. X cubed minus 2x equals x squared. Bring over the x squared by subtraction over to the left-hand side, so you have x cubed minus x squared minus 2x. Maybe you can factor out an x or something, because that's a common factor. And then this second degree polynomial, see if you can factor that. Can you think of two numbers whose product is -2, but whose sum is -1? And that would be what, -2 and +1, huh? So you can factor, again, you have x times x minus 2 times x plus 1. That means either x is equal to 0 or 2 or -1. Okay? So there's your solution set. Okay? Here's another third degree polynomial. Now look, there are closed form formulas to solve any third degree polynomial equation. But we don't necessarily have to use that all the time, only in the most hard luck cases. But this one right here, you can factor by grouping. You know, you can group these first two together, and then you have minus 4x plus 12. We'll write that as negative of 4x minus 12. And then factor out an x squared from the first two terms, so you'll have an x minus 3. And then minus 4 times x minus 3. Aha. Then you can factor out the x minus 3, so you have x squared minus 4 times x minus 3. You have x minus 2 times x plus 2, which is the factorization of the x squared minus 4 times x minus 3. And of course that whole thing is set equal to 0. So that means either x is equal to 2 or -2 or 3. Okay? So that's basically what the solution is. So we factored by grouping. Okay? And solved by factoring. So that's all there is to this, folks. Just a couple more techniques for solving equations. All right. Now that we have gotten some experience in solving equations, in the next lecture we're going to talk about solving inequalities. And the process is very similar to solving equations, but a little bit more complexity. And the result is generally going to be some interval on the real number line. Okay? So take care, and I'll talk with you next time.